For this demonstration with Fathom, we're going to take a look at 4 different mystery collections, and we're going to sample 100 items from each collection, calculate the mean, and we're going to repeat that procedure 300 times, and then we're going to take a look at the distribution of the 300 sample means and see if we can use that to predict the shape of the original distribution of 500 items in the collection. In other words, can we look at the distribution of sample means and use the shape of that distribution to predict the shape of the original distribution? And also we're going to take a look at how the center and spread of the distribution of sample means compares to the center and spread for the distribution of the population. So let's start here with mystery collection number 1. We're going to sample 100 cases since we want to sample 100 values. So I'll do that just to convince you there's 100 items in there. There are 100 items that we sampled. We want to actually collect a mean, calculate a mean for each set of 100 that we get. So here's the mean for this group of 100. And we are now going to collect some measures. And we want to collect the sample means 300 times. So let's do that. This will take a moment. Once this is done, we're going to take a look at the distribution of the 300 sample means and use that to see if we can predict or guess the shape of the original distribution. So let's take a graph here, and here's our 300. Actually, I have 305. I forgot to replace the original 5 cases I had, but that's okay. We can see that this is actually centered maybe around 3.5. Let's actually plot the mean of our sample means. It's about 3.45, 3.46. This is somewhat, actually it looks almost approximately normal, mound-shaped, symmetric. That looks good. So let's see, is our original distribution mound-shaped and symmetric? Huh. Clearly it's not. It's almost like a rectangle. This would be more of like a uniform distribution. But let's see how the mean of the original distribution compares to the mean of the distribution of sample means. So the mean here is about 3.47, here it's about 3.46. The means are very similar, but notice the spread of this distribution is quite a bit smaller than the spread of the original distribution. Alright, let's take a look at mystery collection number 2. So let's sample some cases from this collection. We want to sample 100 cases. And once again, to convince you that we have 100 cases here, we do. We're going to collect the mean every time we sample 100 cases. We're going to have it calculate the mean for us. So there's the mean for that group of 100. And we are going to now collect some measures. We're going to collect 300 measures. And once again, this will take a moment, but we're going to do the same thing that we did a second ago with collection number 1. We're going to look at the graph and see if we can use the graph to predict the shape of the original distribution. So let's take a look at a graph here. So this is this is a graph of the sample means. Once again, it almost looks like it's a normal distribution. Let's plot the mean of the sample means here at about 3.375. So I'm wondering if our original distribution was centered around 3.375, maybe with a larger spread, but I wonder if it was approximately normally distributed. Wait a minute, this distribution is skewed to the right. Clearly this is not a normal distribution. Well, that's interesting. Our first collection was not normal, but our distribution of sample means was normal, and here this is not normal, but our distribution of sample means is approximately normal. That's quite interesting. And notice the mean here is about 3.38 about. So they're both centered at the same value. That's interesting. Alright, let's take a look at our third collection. Maybe our third collection will be normal. One of these has to be normal, right? Let's see. Let's sample some cases. We actually want to sample 100 cases. So we'll do that. And then we're going to collect the mean for each sample of 100 cases. And let's move this down here. And we will now collect some measures. We want to do this 300 times just like we did before. And then we're going to once again generate the graph, look at its center, and see if we can use the graph of the distribution of sample means to predict the distribution for the mystery collection. So let's graph that. This is interesting. Once again, we have something that's approximately normal, though there's like a gap here, but this is interesting. Let's see if we can figure out the mean here, and then we're going to compare it to the mean of the collection. I'm wondering if the collection is approximately normal. Notice we have a range from about -0.2 to about 2.5. This one actually is approximately normal. Although this has a much larger spread than this. So when we take a look at the distribution of sample means, the spread is much smaller. And that was the case with each of the mystery collections. The distribution, or the spread of the distribution of sample means, is smaller than the spread of the original distribution. But this one actually is approximately normal, and the original distribution was approximately normal. Interesting. Right. Let's take a look at the very last one, mystery collection number 4. We'll sample from that collection, but we don't want to sample 10 cases. Once again, we want to sample 100, and we're going to collect the means for each group of 100. And we are now going to collect our measures. We're going to collect 300 sample means, not 5, 300. And we want to turn the animation off, otherwise this will take a while. So we're collecting 300 sample means, and we'll look at the distribution of those sample means and see if we can use that to guess the shape of the original distribution. So let's take a look at the graph here. Although we couldn't predict it for mystery collection 1 or 2. Collection 1 was uniform, collection 2 was skewed right, and both of the distributions of sample means were approximately normal. So I don't know what's going to happen with this one. This could be interesting. Let's take a look at this. Oh, once again, this looks like it's somewhat approximately normal. Once again, mound-shaped, symmetric. Clearly one high value in the middle there. Let's plot the mean. That's about 0.5. Alright, let's take a look at this collection. Oh, this is a weird collection. Look at this. We got 0 or 1. That's the only thing that's in this collection, 0 and 1. So the average of a 0 and a 1 would be 0.5, which is about what this is. Clearly this distribution is not, I don't even know what you would call this, I guess bimodal. There's 2 peaks and everything fell in either 0 or 1. But when we sample from this distribution, it would make sense, since everything they were averaging together is either a 0 or 1, that we'd be right in the middle, somewhere here around 0.5, because you would think about half the time we get a 0, half the time we get a 1, or thereabouts. So this is very interesting. So the mean is still about 0.5 for both of these, and clearly the spread is much smaller. Here we have a spread of 1. Here the spread goes from about 0.37 to about 0.65. So for each of these distributions, we couldn't actually predict the shape of the original distribution by looking at the shape of the distribution of the 300 sample means. However, it's interesting to note that no matter what the original distribution shape was, the distribution of sample means was approximately normal. And that's going to allow us to use the central limit theorem to help us make calculations relative to probabilities with sampling distributions. I hope you've enjoyed this screencast. And for teachers, if you would like a copy of this original Fathom file, please send me a note or post me a note on my YouTube page. Thanks.